All right. Without further ado, let's begin. So, hello everyone. Welcome to the session today. So today's session is on Quarter 5 introductions, the Quarter 5 101. My name is Peter Lee. I'm from the developer relations team here at R3. All right, yeah. So when we talk about Corda, our product, so we have a vision that we have in mind. We want Corda to be the foundation of the future digital economy, right? You can trust our software to build a blockchain for business, and you can expect Corda as a product is applicable to all industries. And also, this is one of our vision is we expect Corda to be highly interoperable with other Corda network, or we also working with other blockchain protocols. So we want to expect Corda to be the to have a cross industry ecosystem. So you can build your, let's say, business on Corda, or your counterparty can build applications on Ethereum Enterprise or other blockchain protocols, and then we will try our best to interoperate with other blockchain protocols as well. And of course, you can easily interoperate or interoperable with other Corda network is what our goal to achieve. So that's basically the top three tagline or visions characteristic of Corda. At the Corda 4 times, right? Today is a session about Corda 5. Then we have to talk about what was it like in Corda 4. So at the Corda 4, we primarily focusing on the four characteristics: strong identities and privacies, higher performance and scalabilities than the other blockchain protocols on the market. And we had a global Corda network called the Corda network, the TCN. And lastly, we focus on enterprise interoperabilities, primarily meaning you can integrate your Corda 4 system with any existing legacy system, or it's easier to build on top of Corda with other level 2 applications. Like, for example, you build a server that working with Corda, etc. So that's with Corda 4, that was the four things that we focus about. And so this is just a chart that sort of give you sort of give you a quick recap about the Corda 4. How does a Corda 4 network looks like? So you have a network with a physical node, you have a public address, and you have a public key, and then the key lives in the physical node, and all the nodes are connected with each other, and in the network there's a node tree. So in a very short summary, to summarize what does it look like in the Corda 4 world, describing the Corda system. So basically it's a permission network that provides peer-to-peer communication on a need-to-know basis. So that's what Corda 4 is about. That's what the Corda 4 look like. So now let's talk about Corda 5. So moving with the next generation of Corda. So we primarily enhance two aspects of Corda. The first one is high availabilities and horizontal scalabilities. So that's request came from our customers who cares about have a highly available service on their for their business, care about horizontal scalabilities to handle instant massive traffic. So with that in mind, so Corda 5 basically fundamentally takes care of it by switching to a different architecture. So in the later slide, I will talk about it. The second one is boosted development experience. So originally, if you have been developing on Corda 4, so for developing, for testing, you gotta go through IntelliJ, and then you gotta deploy and then run on your mock network, etc. So with Corda 5, we develop a new sandbox where you can just deploy your applications in the sandbox, and you can hot load any code changes that happens in your Corda app. So that's just one example of the boosted developer experience. So I'll cover more in the later slide. So yeah, so that's basically the two angles how we enhance Corda from the previous generation to the new generation. And then now let's look at how exactly, or what exactly is changed. So the first thing that's different from Corda 4 times with Corda 5, our next generation of Corda, is we have a new architecture for Corda, brand new. So we bring in Kafka cluster as a message broker to facilitate the communication between those services. So if you are new to Kafka, you can think it as a brain, right? It's an engine where you have stateless service hanging around. So around the brain, and then whenever you want to trigger a service, the brain basically gives a instruction or command, and then those service will respond. So basically, that's how Kafka will come into a place in the new platform of Corda. And with that new architecture, we introduce 4 new concepts. The first one is event-driven workers, right? You know, as I mentioned in the previous slide, the Kafka is basically a coordination system. You still got to have workers to actually implement the job, right? Do the executions. So the first new concept of Corda 5 is event-driven workers, and they are also stateless. So they don't remember what they did, they only just do it. The second concept is virtual node, and I have a whole slide explaining the difference of a physical node as in Corda 4 and then virtual node in Corda 5. The third angle or new aspect is a new plus modular API. So we introduce new APIs, and then we introduce modular API. So if you are close with us in the Corda 4 times, you will know that everything was executed by the Corda physical node, the node engine, and then from the coding level to talking about it was a service hub, right? If there's any developers in the audience, you will know what I'm talking about. In Corda 5, so we basically we separated our service into individual service to make your applications more lightweighted. We also brought in more JSON/REST API to help you better populate your data in and out of the virtual node, the Corda platform. So yeah, more details in the later slide. And then lastly, this is brand new concept. There will not be a comparison between the previous version of Corda and then the Corda 5 because it just doesn't exist, which is the application networks. So application networks basically means it's a brand new way of managing setting up your business network, onboarding customers to join a network, etc. So that's the application network. Okay, so we're gonna actually go into each one of the new concept and then explain a little bit more in details. So the first one, event-driven workers, the working architecture. So So like I already I already explained what it is. In this slide, basically I'm showing you how many workers are there, and then what are they, what are each the workers are for. So there are 7 workers total. On the screen there are different colored, and if we start from the top, that one is very easy to understand, the crypto workers, right? At the end of the day, it's a blockchain. There's a public key, private key, there's encryption. So we have a dedicated service to take care of that. We call it the crypto workers. And then rotating to the left, there's the database workers. It's also pretty intuitive. Anything you generated, you store from the virtual node, you gotta have the database worker to store it. And then one more, the link manager workers. So basically that connects the virtual node with one another. So basically that's how your say network identity will know who to talk to, and how basically the connection is populated. And then the next one is gateway workers. So that's when you have multiple clusters and you're basically, you need to send out communications between one clusters over the public internet to another clusters to be received by the other clusters gateway workers. So that's gateway worker is as its name is to populate the gateway. And then the next one, the membership workers. So that's to serve the application network, which is the last new concept that's were introduced in the Corda 5. So we're gonna talk about that also later. So flow workers is a typical Corda in the Corda family. In the Corda history, flow is just has been there since day one. So when you're writing a Corda smart contract, there's a state, there's a contract, there's a flow. So flow is the instruction that execute your business logic. So obviously we need a dedicated worker to do it. So that's a flow worker. And then lastly is the API/RPC worker. So originally in the Corda 4 times, if you want to generate a flow or you want to trigger a flow from the node to do some things for you, you need to trigger it from outside, right? Either from your own web app, or you are triggering it from your existing legacy system. But you need a bridge, right? You cannot just use curl to directly call to the node. You need a remote procedural call client. And then in the Corda 4 times, we were written it, or like, we teach people how to write it in the Spring Boot, right? We have samples to populate that. But in Corda 5, we basically, you don't need to do it anymore. We took care of it from the Corda platform. So basically, you don't need to write the bridge anymore. We have written for you. So you can just use it. That's also new in Corda 5. So that's basically is the whole family of the worker architecture. And they are stateless, meaning they can be used, the same category interchangeably, meaning, so for example, right now you see there are 3 crypto workers on these Kafka broker clusters. And let's say I have Alice, Bob, and Charlie, right? They all need to do some crypto job to either sign their transaction or whatever. But either Charlie, Alice, or Bob, they will get assigned to a crypto worker to do the signature. But after that process is done, that crypto worker sort of is back to the pool and then waiting for the next job. So yeah, so that's basically what stateless means. Any questions on that? We have a quiet crowd today. It's okay. Okay, all right. So that's the worker architecture. So the worker architecture will give us a few benefits. So the first one is horizontal scalabilities. What does that mean? Right. So I'm going to show you a simple contrast. So at the quarter 4 times, right, everything is running with a physical node, right? Physical node meaning that you need to deal with resource allocation, you need to deal with database sizing, like all that. And when you are hitting performance issue or you're receiving more traffic than you're expecting, you need to basically upgrade the node by basically give more resources to the node. And then if you are hitting the performance or like hitting the same issue again, you need to basically enlarge the physical node to give more resources. So that's how you take care of a quarter 4. Does that solve the problem? Yes, it does solve the problem, but it's just a lot of hassle, right? It worked, but it's a lot of work. With quarter 5, since we are using workers, what we can do is just put the workers on the Kubernetes service and then horizontally spawn more workers. They are simply just creating more replicas of the service that can potentially doing the same job. So you don't care who is doing it for you. They are, again, stateless. So you don't care. The worker doesn't care. They don't have knowledge of what they are doing. They just do it. And horizontal scaling up, meaning you can also horizontally scaling down. That means once you sort of finish your rush hours, you can scale down to 1 workers or even no workers. So that basically meaning you don't allocate any resources for your cluster, for your network identity. So in that case, technically you only gonna spend a very minimal on running a quarter 5 cluster at that point. So that's the first benefit that we sort of, we can see using the new quarter 5 architecture. The next one is also related to the workers, event-driven workers, is the high availabilities. So how exactly we reach high availabilities? So since we have workers, they are interchangeably to be can be replace each other. So that means if one down, the other can just like spawn up and then sub in, right? If 2 down, 2 comes in. So that's basically how we can finally achieve like a hot high availabilities with the new architecture. Any questions on the high availabilities and horizontal scalabilities? All right. Next is talking about the second new concept that is brought in by the new architecture, which is the virtual node. So at quarter 4 times, again, we are working with a physical node. And there's the issue with the resourcing, resource allocations, stuff like that. With quarter 5, you don't need to worry about it because there's no physical node anymore. So everything, again, I keep saying is probably the 3rd time I'm saying it. All the services, all the work is done by the event-driven workers, stateless event-driven workers. So that means the virtual nodes, the concept of a virtual node now is just representing the mapping between processes, data, and identities. So if you think about it, is The network will give you basically identity as who you claim you are. You're gonna generate some data that's gonna store at the database, and you're gonna, every time you want to basically work on that data, you're doing it via a process. And the mapping or the grouping of processes, data, and identity basically is a idea of the virtual node. So it's a abstract concept to have in the Corda 5 world. However, Corda 5 virtual nodes able to represent the equivalent of multiple Corda 5 nodes in one cluster. So that's another sort of controversial point. If you think about distributed or decentralized identity. So at Corda 4 times, if you think about network identity, think about, okay, oh, I have my node, right? So actually for any blockchains, if you think about digital or distributed identity, decentralized identity is like, okay, I gotta have my own node. But in Corda 5, you can't think like that anymore because the virtual node is just a grouping. So what you need to think of is, okay, I gotta own my own cluster. That will be the mentality. You are shifting from, okay, I own my own node, it's just a tiny node, it's represent everything, to if I really want to own my identity, I need to own a cluster. And on that cluster, I can host my identity, I can host my wife's identity, I can host my child's identity, I can host my friend's identity. So basically, you are promoting yourself from a node manager to a cluster manager to really hold on to your sovereignty in sort of the decentralized or distributed world. Because if you don't do that, what you are holding on to is just an identity in someone else's cluster, right? Because if you think about it, someone else's cluster is providing you service to do your blockchain transactions. Someone else's cluster is holding on to your data. You are sort of giving them permission to read and write the data into a database, probably not owned by you, by someone else, whoever is controlling the cluster. So that mentality you need to change, right? So once you shift to thinking about, okay, if I really want to own everything that I generate on the Corda 5 system, I need to own my own cluster. So let me actually speak a little bit more on that. So why exactly did we switch off from everyone else own their own node to someone can own clusters and then someone can just like, nah, I don't care. I just want a identity in any cluster, because at the end of the day, it's just cost. Owning a node, I mean, to our customers, is nothing, but it still is generate cost. So some of the smaller, medium-sized business partners, they don't want to own their own node. They are willing to share the resources with someone else. So basically, Corda 5 is basically the new architecture give them options to participate with a cheaper entry ticket. So that's basically what it is. And then for our large customers, of course, they're going to run their own clusters. They don't care if they only have one node on their clusters, or they have all their customers, the Corda identities in their clusters. They don't care. So so basically, Corda 5 offers a cheaper ticket to get it. Yeah. Okay. So I see there are two questions. So what's the difference between Corda 5 virtual networks and the business network that each Corda 4 node is involved with. Okay. We have a section on the application network. I will address that later. What virtual node really is at a technical level? Is it a VM container or something else? It's on the screen. It's a mapping. So okay, so let me show it. So yeah, next slide. I gonna have it, but right now let me finish on this slide. So in a cluster, you can basically have a multiple Alice, multiple Charlie, multiple Bobs, and each one of them, they are just a identity mapped with some service or database that working for it. And even though they are Alice, but of course they're gonna have a slightly difference on their X500 certificate, or they're registering with a different network. So again, so the last section we talk about application networks, they're gonna explain the difference. So basically now in one cluster, you can run your multiple network, multiple business network. So Alice is the same person, but Alice participates in network 1, and then Alice, the same person, participate in network 2, right? So and all of that can happen in one cluster. Okay, so that's that. The question, is there a ceiling on the number of virtual nodes per instance? Right now, we haven't do too much of the pressure testing or stress test, but as far as I know, we don't have a hard-coded boundary on the limit. But I mean, we have to let the experience to start, you know, kick in, like what the fact start kicking in. Like for example, how big, how much RAM you are giving to that cluster, how much, what's this, how many CPU are you giving to that cluster? So it's a dynamic question. In this diagram, is each network 1, network 2 a business application network? Yes, they are. Okay, all right, next. So what's the physical format of a virtual node, like on the technical level? So at the Corda 4, it's very easy to understand. The identity register with a node, because every node has an X500 name. That's it. Like that's straightforward. You deploy your app in the node, and you get your network to register with the X500. So that's it. One node, one identity, one network. With Corda 5, we have a big instance called the Kafka clusters, and in the Kafka clusters, there are multiple database, right? Vault, that's the database, multiple, right? If you can imagine, there's so many more, and they will be workers to. There are 7 workers for one node, and then all, like, I mean, not for one node. If you want to operate a virtual node in Corda 5, you need 7 workers. But you can imagine in a pool that in a pool you can deploy 100 workers. So on top of that, the database plus the workers equals the virtual node, and then the virtual node is just gonna have a tag saying, okay, who I am, Alice, Bob, or whoever. And then on top of the virtual node is you can deploy your app to it, and then the app gonna store in the database, and then the app gonna have a basically gonna tag with a virtual node. So you are installing the app to the virtual node, and then the identity also is marked on the virtual node when you create it. And then so all that combinations together, so that's where your network is. So basically, this chart sort of is tagging is stacking the components randomly. But let me sort of give you an order. So the first thing gonna happen is you deploy the Kafka. Hold on, let me draw on this. red. So the first thing gonna happen is the Kafka cluster. And the second thing is you're gonna deploy the workers, right? Once you deploy the workers, now you are giving identities to your applications. You will need to define what you want to do. So the application actually happens is a third thing. So once you deploy, you're defined, okay, I got to create a network to do this. And then the fourth thing is you are creating the virtual node. And then once you create a virtual nodes, the identity happens automatically. So that's 4.0, 4.1. Oh, and then the network actually happens when you define the app. So that's like 3.1. So again, let's look at it. The first thing is you do the Kafka clusters, and then the second thing is you do the workers, right? The vault is just a service, so it's sort of, this is also okay. Let's just say 2.1. So the database and the worker happen at the same time. And then the third thing is you need to define what you want to do, right? Once you know what you want to do, you set up the network. Because you just define what you want to do, and then you basically you need to have a playground, right? So the network is a playground. And then once you do that, you create a virtual node. You take the network informations as a parameter into the virtual node deployments. And then once the virtual nodes is creating, and then the identity is automatically formed. So that's basically 1, 2, 3, 4. So that's basically how it goes. Let me see, there are some questions. So that one's Alice in network 1 and Alice in network 2 have the same vault. No, they don't. So that question is still on the previous chart. So Alice in so question is, Alice in network 1 and Alice in network 2 have the same vault? No, they are separate. But I mean, if you want to, but by default, they're just completely different. So you can think Alice in network 1 and then Alice in network 2 are two they are independent from each other, right? That's the right word, independent. But if you still want to map the database into a same database, it's possible. But I'm not sure. Right now, we haven't tried it, but we don't know what can go wrong. But by default, they're independent. Yeah, so that question is answered. Next one. So if we assume a multi-tenant settings, the infrastructure that hosts the cluster will have private keys of all tenants. There is no proof of ownership of the key, as the key is not managed by the tenant. Correct. Right. So multi-tenancy is available in Corda 5 because of this architecture, but sort of the trade-off of multi-tenancy is you gotta be super clear of who's the parent hosting instance, because that parent hosting instance can, well, in a very simple example, can shut you down anytime, right? If you really think about it, the Kafka cluster owns it all. So yeah. Another next question. Alice in network 1 and Alice in network 2 would have the same identity, same key pair, right? No, they are independent from each other. It's just they are the same person who controls two Corda identities in the same cluster, doing different things, independent from each other. But at the end of the day, it's the same Alice sitting behind the laptop. So if that's more clear, simple to understand. Next question. How is managed data segregation on Vault between different Corda 5 instance on the same virtual node? Good questions. Okay. So right now, I think all the data are storing in the same database, but actually I didn't look into the database and how exactly they're stored. I mean, according to my current understanding of the segregation of data is they will be mapped with different identities, but I can check on that. Another thing is I think if I remember correctly, there is plan to basically allow each tenant of the same cluster to connect to their own database, but I need to check. I need to check again. Maybe I read it wrong, but it might. But right now it's just the same database. Yeah, related quite different database scheme. Yeah, probably. So because at the end of the day, is as I mentioned, different identities in the same cluster, they are just isolate with each other. So Alice is Alice, Charlie is Charlie. And if you follow our coding examples and actually deploy it locally, you will see that you can't query Charlie's database if you are using Alice identity. Yeah. So that's that questions. Is there a one-to-one mapping between the virtual node and an app, or can a single node host multiple app? Okay, so that questions actually that was a Corda 4 mentalities because originally in the Corda 4 world, since you are working with a physical node, you have to deploy multiple apps into the same Corda node. But right now, everything is virtual. So basically, if you have a multiple apps, you are going to create multiple identities to serve in different apps. So that's the default thinking about virtual nodes. I present Alice as a persona that acts in network 1 and network 2, not having the same identity post challenge in interop scenario where the same persona use distinct networks. Not having the same identity. Okay, so you mean interop scenario? What do you mean? Like Alice in network 1 interoperable with Alice in network 2, or or are you talking about Alice in network 1 interoperate with Bob in network 2? So that can you elaborate that a little bit? Yeah. So a virtual node is a partition in database. How does the concept of accounts has been handled in Corda 5 if at all? So there's no accounts in Corda 5. And yes, virtual nodes is a partition of the database. So you can think virtual node is account. Identity is dedicated X509 certificate like in Corda 4, yes. Alice need to act on the, okay, I need to check time. Okay, so let's pause on the question a little bit. So let me finish what I have for the next 2 sections, and then I can continue to answer question. Okay, so the third one is new plus modular APIs. So this one is pretty simple. So basically, originally in Corda 4 times, everything is handled by the service hub, right? If you've been coding in Corda 4, you know what I'm talking about. If you know, if you haven't, just think about the physical node was doing all the work for everything, right? But right now in Corda 5, there's no physical node. It gives us the ability to present you what's behind the hood of each layer, and then you can decide what you want to use. So basically, there are 4 layers of Corda 5 service: the network interface, the workflow, shared ledger, smart contract. And this basically is a detail of what's going on in each layer. On the very bottom, the network interface is the P2P layer, is how a virtual identity is connecting with other virtual identity. There's no blockchain at all. There's not even Corda on that layer. So it's just purely Kafka managing the service between an identity to another identity. So that's the network interface. The workflow is where you can send sessions or send Corda flows between one another. You can send a ping, you can send other informations among one another's, but you can store that data because the next layer is the shared ledger layer. So that's where the UTXO come in. That's where the blockchain actually happens. So that's the third layer, is the shared ledger, and then the last one is the smart contract, is where the consensus, the node tree comes in. There's the more at the SDK comes in. So that's basically the last layer. That's where your Corda app gonna comes in. So that's basically the 4 layers of the new one. No, not the 4. That's the 4 layer, not new, but that's the 4 layers of what used to happen in Corda 4 in the node service, but now we are sort of, because of the architecture revamp. So now we are opening up layer by layer for you. So you can decide how much service you want to use. So for example, if you just want to have a you just want to have a full-fledged Corda applications, smart contract, blockchain, notarizations, all of that, you need all 4 layers. But if you just simply want to write like a message app, a chat app, you don't need you don't even need blockchain in that app. You can just use the network interface, because at the end of the day, it's just Kafka broadcasting information to another identity, another receiving the gate of the Kafka cluster. So that's that. The last one is application networks. So I mean, I pretty much I was talking about this the whole time. So basically, the application network is, if you're thinking about the Corda, if you know what happened in Corda 4, so basically Corda 4 is you get your own you get a X509 from a network, and then that's basically is your service address in a network, right? So basically you got to sign up with the network first, and then you get your node, and then you develop your Corda, right? So that's what happened in Corda 4. But Corda 5, what happened is, of course, you got to have a cluster somewhere, right? Cluster first, and then second is you define the network, as I was drawing in the previous slide. So you define your networks, and then you take the network parameters, you use that as a parameter to build a Corda app package installer. So that sort of is just it's a network. It's a labeled installer with the network information already in that installer, and then you create your own virtual node. Again, just some mapping with some service, and then you install that Corda app installer into the virtual node. And then when you do that, your virtual node will automatically picks up which network that virtual node is going to operate. So that's basically solves all the hassle of onboarding a new customer, of you gotta issue the X509, you gotta issue the Corda app, you gotta make sure that he's all configured. You don't need to do that in Corda 5 anymore. All you need to do is the network operator create a Corda app installer, and then whoever he wants to onboard it next, just send him a copy of the installer, and then the customer, the new client, the person who are going to get onboarded, install that CPI, the Corda package installer, with his newly created virtual node on a cluster, whatever cluster that he wants to run his own virtual node at, and then boom, he's connected. So that's basically, this is saves a lot of time. This is gonna be a very amazing new features that's all of our customers gonna like, because you just don't need to deal with customer onboarding anymore. So that's that. And I mean, this diagram is the step of how you actually do it. Yeah, it's just a little drawing. And yeah, that's basically is the 4 new things coming with the Corda 5, the event-driven workers, right? Because of that, we are able to do high availabilities and the horizontal scalabilities. Virtual node is a new concept. Forget about physical node. It's just a mapping between identities and different stateless services. New plus modular APIs is you get more flexibility of what you want to build, what you can build, and basically give you more option of using Corda for not just blockchain. But of course, we hope you use Corda for blockchain. And then lastly, so this is a killer feature. Remove all the hassle about onboarding new customers and setting up the network. Yeah, so that's the application network. Okay, so let me back to the questions. What's the difference between the Corda 5 virtual network and then the business network that each Corda 4 node is involved with? I think I answered that in the last sections. Okay, so that's the more on the Alice thing. Okay, so let me answer other question first. So Corda apps will be deployed on the network or on the virtual node. So the Corda app is deployed I wouldn't say on the network. So because a network parameters or configuration is written first, and then you use those network parameters and the informations. Well, I mean, they actually have a name called the groups policies, right? Your network group, right? So basically you define a network first, and then you take the network information and then put them into the Corda app installer. So the Corda app installer will carries all the information about that network, and then you install that Corda app installer to the virtual node. So again, to your questions, you say Corda app will deploy on the network or the virtual node. Both is not exact, both either or. So basically is you take the network information and then you install it to the virtual node. You can actually deploy it. The virtual node is not a physical thing. You install it into the cluster and then linked with your virtual node. So that's done. What data structure does Corda 5 use? Merkle tree, DAG, or others? I didn't read about any updates on that. I think it's still Merkle tree because in quarter 4 that's what's used, but I can check with engineering again with that questions. You seem to privilege the multi-tenant setting only. I need to understand how this works when you have one physical node hosting multiple nodes. Again, you know, one physical cluster hosting multiple nodes in interaction with other physical cluster node acting the same app network. Yeah, so that's basically what you are describing is the multi-cluster setup. So that's actually what will happen in the real production world when quarter 5 sort of is ready for production. The GA is in 1 month, but you know, every software probably needs some like stabilization time. But once it's ready for production, what's going to happen is every big customers, they will have their own clusters. And if they only are hosting for themselves, not thinking about hosting for someone else, their own clusters will only have one node. Is there only one virtual node is their own identity. And that virtual node will connect with other big customers' clusters and then doing work with their virtual node. So basically, in quarter 4, you are hosting a physical node, but in quarter 5, you are hosting physical clusters. And then in your own physical clusters, you can deploy as many physical virtual node as you want. Is all your name. So that's one setup. Legitimately for, you know, big customers, they don't care about cost, they don't care about hosting for others, they care about the privacy, security of their data. They are not sharing their cluster with anyone else. So that's that. There will also be customers. There also be customers, but they have smaller clients. Their customers, they don't want to set up their own clusters. They don't want to spend the money, spend the time to managing that. So they will go to their respected partners. Let's say they nominate one big customer. Let's just say Accenture, right? They go to Accenture and say, okay, 10 of us, you know, we all trust you. So Accenture, please, you host a cluster for us. And then we are just virtual nodes. We trust you. We will host our data at your clusters as long as we can do work with, let's say, another big clusters virtual nodes. Let's say Tata Consulting, right, has another big cluster, and in Tata Consulting's cluster has another like 10 smaller nodes. So that's basically the second scenario. And then that's the multi-tenancy scenario. And you say, yes, the multi-cluster setup should be a general use case, I believe, and then they need to share common application network. So application network, it has nothing to do with infrastructure setup. So regardless of whether you are a virtual node, you mean just a node, or you are a cluster host, and also you have your own virtual node in your cluster. Application is an abstract idea that is just basically you get a URL from your counterparty, and then your counterparty say, here's a URL, join my network, and then you put that into you give that to your virtual node, and then your virtual node can automatically start transacting with your counterparty. So that's the application network. Yeah. So if you really think about the application network, it's like a URL. You have to get the URL to participate in that network, to join the game. Last question. So how is no-trace service being handled? So no-trace service is still being handled the same. It's still examining the UTXO. doing the UTXO model, examining the unspent transactions input, right? Well, no, unspent transaction output. If the output is being used by some transactions, the notary will record that states hash. So that next time is see the states hash again. So in a new transaction, the notary will red flag the transaction saying, okay, I have seen this output before, so you cannot use in a new transaction as input because that's a double spend, right? So that's notary does not change. All right, so seems like that's all the questions we have for today.